Good afternoon, everyone. ఒక్క నిమిషమా వస్తుందా? ఓకే, వాల్యూమ్ ఓకేనా? వస్తుందా? ఓకే. और एक चाहिए ఇంకా అక్కడ ఉన్నట్టున్నాయి वहाँ पे हैं शायद देखना नहीं तो और लाना. So those are the formulas we require for differentials and integrals. Is that okay? Okay. So today's session would be a refresher kind of a session on differentials. Some kind of differentials we'll try to solve, and then some kind of integrals methods as well we'll try to solve. And then I will give you some brief on two-dimensional geometry, certain basics, that's it. Okay? Fine. What's in the formula sheet out in this? Raju, we require those formula sheets. Okay, na? Fine. So there are certain formulas in differentials. So before going further, let me just explain you. Suppose if I have a curve, some y equal to f of x, y equal to f of x, some curve, y equal to f of x curve. So quite obviously everyone knows x we call it as an independent variable, y we call it as a dependent variable, the value of which depends on x, and also how we define the function f. Okay, now whenever there are some changes in x, correspondingly based on the definition of the function f, we'll have corresponding changes in y as well. It means if we have certain extremely small changes in x, we'll have corresponding changes in y as well. It all depends upon what kind of changes that we have in y. It all depends on the function, the definition of the function. Okay, now in this context I don't want to go deeper into what are the limits, what is left hand limit, what is right hand limit, when do the limit exist, and what is continuity after that, and what is differentiability. I'm not looking after that particular element of the concepts of limits, continuity and differentiability. Okay, that is something which you will be learning in due course of time, which you already know in fact for that matter. Okay, but as of now, today's session, I assume that the functions that we are talking here, f of x functions, the limit exists, they are continuous, and also they are differentiable as well. Differentiable as well. They are differentiable functions. Okay. Since when I assume that the function f of x is a differentiable function, whenever we have extremely small changes in x, corresponding changes you can always see in the dependent variable y. So there is something called as a slope or a derivative, which we call it as delta y by delta x. So it is nothing but for corresponding changes of delta x in x, what would be the corresponding changes in y, which are delta y. So we take it as a gradient delta x, delta y by delta x. Now here there are multiple scenarios. One scenario is that y, the dependent variable y, totally depends on the independent variable x alone. Only on x it depends. The other cases might be that z is some function of x's and y's also. X's and y's also. In this context, we have two independent variables and one dependent variable dv. So any changes in x will be reflected in z, changes in z. Also any changes in y also correspondingly will have some changes in z. Okay, therefore the changes in z partially depends on changes in x and also partially depends on changes in y. Here also, when I say that there are certain changes in x, there will be certain changes in z, we call them as delta z by delta x, or similarly delta z by delta y also we can have. But to distinguish between this concept and this concept wherein you have only one independent variable, this concept we have more than one independent variable. It can be two independent variables or three or four or n independent variables. So to distinguish between them, we actually write this as dy by dx, dy by dx, which always tells us that the value of y or the changes in y totally depends on changes in x alone and nothing else. In the case of here, we write it as dou z by dou x and dou z by dou y. Instead of d, we write dou. Whenever you see dou, it also always means that there is a partial derivative. Partial derivative comes into picture whenever you have more than one independent variable. Quite obvious. We already know this one. Okay. I'm just trying to refresh you all guys. So whenever you have more than one independent variable, it also means that we are going to have partial derivatives. And to get into the context, this we have only two variables altogether, one independent, one dependent. So two variables, therefore I am talking here only two-dimensional geometry. This is 2D geometry. When it comes to here, more than one independent variable, that means minimum two independent variables would be there. 2 plus 1, 3 variables. We are talking here three-dimensional geometry. If at all I have 3 independent variables, it means I am talking about fourth dimension. 4-dimensional geometry, 5-dimensional geometry, nth dimensional geometry, you can always think or visualize in this context. Okay, so geometrically, visually, you have to ensure that yes, when I'm talking about dy by dx, I'm talking about 2-dimensional geometry. When I'm talking about dou z by dou x or dou z by dou y, somewhere underlying it is multi-dimensional, not just 2-dimensional. Clear? Okay. Now, if dy by dx, let us stick on to 2D geometry first. Later on we can move on to partial derivatives as well. That's not an issue at all. But let us come back to this concept. Okay. So now having said 2D geometry, we are talking about dy by dx alone. Okay. So there is only one independent variable based on which I have another dependent variable y. So there are certain formulas. Inka vilada meeku? ఓకే నాకు ఒకటి ఇవ్వండి రెండు ఉన్నాయి మీ లైన్లో ఓకే ఒకటి ఇవ్వండి చెప్తా సో హియర్ వీ హ్యావ్ గివెన్ యూ సమ్ డెరివేటివ్స్ సో సమ్ కామన్ డెరివేటివ్స్ ఓకే ఐ థింక్ ఎవ్రీ వన్ నోస్ దెమ్ మేబీ suppose I have x power n differentiation of this with respect to x. In fact, generally we are supposed to write like this. It's f of x actually, a differentiation of f of x with respect to x. Okay, but yeah, people keep writing in their own ways. This is nothing but n into x power n minus 1, n into x power n minus 1. And of course the differentiation of constant is always 0 because there will not be any changes in that. Okay, then since there are no changes, therefore the differentiation with respect to x would be 0. And what is differentiation of sin x? Differentiation of sin x would be cos x. Similarly, differentiation of cos x would be minus sin x. So I don't want to write all of them here. Anyway, all of them are given listed here. So I just read out so that you can refresh them. Okay. So differentiation of x power n is given, n into x power n minus 1. Differentiation of sin x is cos x. Differentiation of cos x is minus sin x. And differentiation of tan x is secant square x. And differentiation of secant x is secant x tan x. Differentiation of cosecant x is minus cosecant x cot x. And differentiation of cot x is minus cosecant square x. And blah 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 blah. And one important thing here is differentiation of e power x is e power x itself. Differentiation of e power x is e power x itself. Differentiation of log x is, we write it as 1 by x, but that all depends upon the base. If it is e the base, when I talk about, let me come to this logarithms. Logarithms, log x to the base e is always a natural logarithm. Natural logarithm. We can even have log x to the base 10. So base 10 logarithms, or sometimes if you call it as log x to the base a, some value of a, base a logarithms. Okay. Now if it is log x to the base a, this can also be written as log x to the base e, then into log e to the base a, into log e to the base a. Log e to the base a is nothing but 1 by a, so you can always write it as is equal to log x to the base e. Okay. Do you remember all logarithm formulae? Pakka? Adagana? Since this being a refresher class, therefore I can ask you anything. Okay. So what is log AB? Log AB. Okay. Log A into B, whatever is the base, okay, is log A with the same base. Suppose if it is E, log A to the base E plus log B to the base E. Similarly, log A by B is equal to log A minus log B. Okay. Itla logarithm vachindi kabatti you complete chesedam ayipothundi. Okay. And then suppose if I have something like log A power n, log A power n, n times of log A itself, n times of log A. Be clear here, this is not same as log A whole power n. Both are not the same. Okay? Fine. And both are not the same. Dialogue gurtosta untadi manaki. Balakrishna dialogue. Balayya. Okay. Whatever. So log A to whole power n is different from log A power n. Log A power n. Okay? Anyway, so log E is always equal to 1. In fact, log A to the same base is always equal to 1 for that matter. Okay. So if nothing is mentioned here in logarithms, it means that it is always a natural logarithm. If nothing is mentioned, it is always a natural logarithm. If some base is there, it has to be specifically mentioned as log x to the base a or log x to the base 10. It has to be mentioned at any cost if it is not a natural logarithm. Okay. Anyway, suppose if at all I have log x to the base e is equal to a, suppose, assuming that log x to the base e is equal to a, it also means that what is x? X is always equal to e power a. X is always equal to e power a. In fact, you can go back also. If I apply logarithm here, logarithm to this expression or this equation, log x equal to, in fact is log x equal to log e power a, and we have this formula. This is nothing but a log e, and log e is nothing but 1, which is equal to a. So log x equal to a. Okay? Anything else in logarithms? Good enough? Fine. So basic logarithmic expressions are complete. Suppose if at all someone mentions that differentiation of log x to the base 10, log x to the base 10, okay? Log x to the base e is 1 by x, is which we know already, but log x to the base 10, so this is nothing but differentiation with respect to x of log x to the base e into log e to the base 10, and this is anyway is a constant, therefore constant anyway comes out of this differential, which is nothing but log e to the base 10 is 1 by 10 itself, and differentiation of log x to the base e is 1 by x. Sorry, 1 by log 10, sorry. Okay, 1 by log 10, right? 1 by log 10 into differentiation of log x is 1 by x. Clear? Right? Okay. Anything else that I need to mention? And differentiation of hyperbolic functions, you know them. All these things you know anyway. Okay? Okay. You take this. Okay. So all those formulas you can refresh in this document itself. But what I will do is, I will go with some other basic properties of differentials. So differentiation of some function of x plus another function of x. Differentiation of some function of x plus another function of x is obviously equal to differentiation of f of x plus differentiation of g of x. Plus or minus, even minus also, it's the same thing. Okay? And then differentiation of two functions, maybe u and v, where u and v both are functions of x's, then this should be product formula, we call it as differential of the products. Now what is this? U into differentiation of v plus differentiation of u into v, uv formula. Sometimes we also write it as u into v dash plus u dash into v. So the dash is a shortcut form, a symbolic representation of differentiation with respect to x. Okay. Now the problem again, what comes in your exam is that, so if you have something like a df by dx, you are supposed to write df by dx. Okay. Now you will f of x, suppose. You have the habit of directly writing it as f dash of x. Or somewhere if you have dy by dx, you write it as y dash. Or higher order, d square y by dx square, you write it as y double dash. We generally have the habit of writing like that, in short forms always. Or some people even write this as y1, this as y2. But this is not the universally acceptable representations. Nowhere it is given that y dash is dy by dx. We assume that, let us assume that dy by dx equal to y dash or y1. But whenever you use y dash or y1, you have to specifically mention that where y dash is equal to dy by dx or y double dash equal to d square y by dx. You have to mention in your answer. Without mentioning that, The evaluator will not know that y dash is dy by dx or y double dash is d square y by dx square. And one more thing, in whatever you write in your final examination, the evaluators, as I mentioned to you, they're all senior professors. Okay, they're all professors. Generally, they will be very senior professors. Okay, and they are from an academic setting. Academic setting means they are from any of the universities. Professor in a university is a very typical kind of a person, where since he is coming from academic background, not engineering background, none of engineers are going to evaluate your answer scripts. Engineers will accept y dash and y double dash, but academicians will never ever accept y dash and y double dash unless otherwise you specifically mention y dash is so and so, y double dash is so and so. Is that clear? Okay, fine. That's how people lose marks. Instead of out of 10, instead of getting 7, if they get only 6 or 6.5, they don't understand why he or she is getting 6.5 or 6, because of these kind of silly mistakes that you do. Anyway, so this is product formula. Similarly, we have another formula, d by dx of u by v, which is v du minus u dv du by dx dv by dx by v square, or sometimes you also write it as v u dash minus u v dash by v square, to put it in very short forms. Okay. Okay. We'll solve some questions and then move on to further other areas. Now, soft copy of this anyway I'm going to provide it to you. Soft copy of this one, this entire document. But some of the problems we'll solve here. Rest of them you go home and try to practice them. Okay. So find the differential of or derivative of seven x power 4 minus 2x cube plus 3. So obviously it is 28 x cube minus 6x square. Differentiation of constant is anyways 0. Okay. So d by dx of 1 plus 3x square into 2x cube minus 1. Awesome. Here also. Anyone else require handout? Everyone got it right? So quite obviously UV, therefore 1 plus 3x square into differentiation of this, which is 6x square, plus differentiation of this 6x into 2x cube minus 1, whatever it comes out to be. Okay. One more, d by dx of x square minus 1 by x square plus 1. X square minus 1 by x square plus 1. So it is u by v, v du minus u dv by v square. So x square plus 1 into differentiation of numerator 2x minus differentiation of this 2x into x square minus 1 by x square plus 1 whole square, and whatever it comes out to be. You can do that. Standard formulae, anyway you are given all these formulae. Okay. Just calling so many times. So let me go further. D by dx of tan inverse 1 plus x by 1 minus x. D by dx of tan inverse 1 plus x by 1 minus x. ఓకే అంటే ఇంకా చిన్న చిన్న ఎన్ని సాల్వ్ చేస్తాం ఒకసారి పోదాం జంప్ కొడదాం ఓకే సో జనరల్లీ వాట్ వీ డూ I will treat this entire bracket 1 as suppose equal to y suppose. I am supposed to find what is dy by dx. Okay. Now if I put y equal to tan inverse 1 plus x by 1 minus x, this also means that tan y is equal to 1 plus x by 1 minus x. Now you can differentiate this one. You can directly differentiate this one. So differentiating this entire equation, what I get? What is differentiation of tan x, tan y? Differentiation of tan y. Secant square y into differentiation of y, which is dy by dx, because we are differentiating with respect to x, not with respect to y. Had it been only with respect to y that I am differentiating, then it would have been secant square y. Since I am differentiating with respect to x, it is secant square y into differentiation of y with respect to x, which is dy by dx, equal to differentiation of this u by v. ఏది నేను దీన్ని డిఫరెన్షియేట్ చేయట్లా, దీన్ని డిఫరెన్షియేట్ చేస్తాను. నువ్వు చెప్పింది కరెక్టే. దీన్ని డిఫరెన్షియేట్ చేస్తే అట్లా వచ్చేది. అంటే 1 by 1 plus x square అన్నాం అనుకో, అప్పుడు 1 by 1 plus x whole square by 1 minus x whole square ఇంత అవుతుంది అని చెప్పి ఇట్లా చేస్తున్నాం. సింప్లిఫికేషన్ అంతా. ఓకే. అండ్ దిస్ ఈజ్ ఈక్వల్ టు డిఫరెన్షియేషన్ ఆఫ్ 1 plus x by 1 minus x is 1 minus x into v du. Differentiation of numerator is 1 minus 1 plus x into minus 1 divided by 1 minus x whole square. Is that okay? And this comes out to be equal to 1 minus x minus of 1 plus x divided by 1 minus x whole square. ఏమైతుంది అది? minus 2x by 1 minus x whole square. Minus plus అవుతుంది కదా, రైట్. ఇన్ దట్ కేస్ ఇది 2 వస్తుంది. ఓకే, 2 by 1 minus x whole square. What is this? This is secant square y into dy by dx. Again, if tan y is 1 plus x by 1 minus x, what would be secant square y? Tan y is this, secant square y. Convert చేయాలి కదా everything, because I want dy by dx now. I want dy by dx only, which is nothing but, if we go to the side, this becomes 2 cos square y by 1 minus x whole square. But this cos square y, you have to convert it into in terms of x's. Okay? ఏం చేద్దాం? ఇక్కడ secant ఉంది కదా ఆల్రెడీ, secant square. So secant square minus tan square equal to 1. Okay? So 1 plus tan square becomes secant square. So secant square, you put it as 1 plus tan square. Okay? So this comes out to be equal to 2 by 1 minus x whole square. Ikkada 1 plus tan square. Tan square is what? 1 plus x whole square by 1 minus x whole square 1 by whatever it comes out to be after complete evaluation. Okay. Anyway, like this we have so many questions. Anyway, you will get them in your ఏది ఇదా? దిస్ ఈజ్ నథింగ్ బట్ 1 by secant square కదా. ఇప్పుడు secant square కి tan square కి ఫార్ములా ఏంటి? ట్రిగ్నోమెట్రిక్ ఫార్ములా. ఓకేనా? secant square theta minus tan square theta equal to 1. Therefore secant square theta equal to 1 plus tan square. సో ఇక్కడ నాకు secant square y ఉంది. సో 1 plus tan square y. 1 plus tan square. What is tan? ఇది. సో అది సబ్స్టిట్యూట్ చేస్తాను. సో రకరకాల ఫార్ములాస్. ట్రిగ్నోమెట్రీ ఆల్సో యూ హ్యావ్ టు బి వెరీ గుడ్ ఎట్ ట్రిగ్నోమెట్రీ ఫార్ములా. Okay, trigonometry really plays very important role, especially those formulae, trigonometric formulae. Not just always sin square theta plus cos square theta equal to 1. Anyway, that is there. Okay, let me refresh that again in that case. Trigonometry. So one basic formula is, don't ask me sin theta equal to 1 by cosecant theta, all those stuff. Okay, some basic form. Secant square, sin square theta plus cos square theta equal to 1. And then secant square theta minus tan square theta equal to 1. Cosecant square theta minus cot square theta equal to 1. Okay, sin 2 theta, 2 sin theta cos theta, cos 2 theta, cos 2 theta, cos theta sin theta minus sin theta cos theta na. sin 2 theta చెప్పారు. cos 2 theta, cos 2 theta is sin square theta minus cos square theta, sin square theta minus cos square theta. Okay, cos 2 sir correct. నేను కూడా మర్చిపోతాను, ఆబ్వియస్ మర్చిపోతాను నేను. cos 2 theta, let me write it so that అది ఇంప్రింట్ అయిపోతుంది. cos 2 theta is cos square theta minus sin square theta. Now here there are multiple variations that are possible in our this thing. Cos square theta is 1 minus sin square theta, therefore 1 minus 2 sin square theta. Again sin square theta is 1 minus cos square theta, therefore this becomes 2 cos square theta minus 1. Okay, now suppose somewhere down the line, somewhere you might require to simplify this cos square theta. Suppose somewhere you need to integrate cos square theta. Integral of cos theta we know, but how to integrate cos square theta? Okay, in such cases you might require to simplify this cos square theta. From here you will get cos square theta. Cos square theta is nothing but 1 plus cos 2 theta by 2. 1 plus cos 2 theta by 2. Now integration of this becomes easy in later cases. Similarly, sin square theta is nothing but 1 minus cos 2 theta by 2. So this rearrangement of terms, especially in trigonometric terms, is something which is always, you need to remember them. Okay, you cannot forego or forget these kind of things. Again, sin a plus b, sin a plus b, sin a cos b plus cos a sin b. Okay, sin a minus b, obviously in between you get minus. Cos a plus b, cos a cos b minus sin a sin b. Now you tell me what is sin a cos b. So basically 2 sin a cos b, we can always get it as sin a plus b plus sin a minus b. Sin a plus b plus sin a minus b is 2 sin a cos b. Therefore whenever you have sin a cos b is nothing but half of sin a plus b plus sin a minus b. Okay, similarly if at all I have 2 sin a sin b, 2 sin A sin B. This will be in terms of cos actually. So cos A plus B and cos A minus B, you need to work it out. So cos A plus B is cos A cos B minus or plus or? Cos A plus B in formula? Cos A plus B equal to cos A cos B minus sin A sin B. Okay? Cos A minus B is? Plus sin A sin B. Okay? Now, if I add both of them, what I am going to get? 2 cos A cos B. But what I have is sin A sin B. Therefore, I need to subtract both of them. When I subtract them, here always minus sin A sin B is there. Minus of sin A sin B is minus 2 sin A sin B I will get. Okay? Since I have plus here, or maybe I would put minus 2 sin A sin B. Okay? So somewhere all these things you have to do in your mind itself. You cannot keep on writing all these formulae in the back of the sheet and then try to compile there. Okay? All these formulas should be somewhere here. Okay. Now can anyone tell me the relationship between sir, what is tan 2 theta formula? Tan 2 theta? Before that, tan A plus B will see, so that it becomes easy for you. Okay? Tan A plus B is what? Tan A plus tan B by 1 minus tan A tan B. If A equal to B equal to theta, it will become tan 2 theta. Okay? So 2 tan theta by 1 minus tan square theta. 2 tan theta by 1 minus tan square theta. గుర్తుపెట్టుకోండి వస్తుంది మనకి somewhere we'll get these kind of things in the final somewhere some of the questions. Okay, ఎన్ని వస్తాయి all of this will come somewhere. Okay, tan 2 theta. Now you put this tan 2 theta or maybe cos 2 theta and sin 2 theta in terms of tan theta. 2 tan theta by this is 2 tan theta by 1 plus tan square theta. గుర్తు పెట్టుకోండి పనికొస్తాయి ఇవన్నీ. ఓకే, cos 2 theta 1 minus tan square theta by 1 plus tan square theta. All these things you will get them somewhere. Got it? Okay. My suggestion is, if possible, try to catch hold of your plus 2 level book. Okay, just once. Anyway, most of the things I am giving you. Some of them, if at all I miss something, just go through them. Just formulas. That's it. Nothing else. Okay, just formulas. Okay. Okay, so differentiations, whenever you have a parametric notation. Parametric, what is parametric? Parametric notations. So parametric notation means that not just y and x's and y's, there will be another parameter. Might be suppose time, t as a parameter, or something else, r, displacement vector, that might be a parameter. Okay, that means x can be written in terms of another parameter t, y can be written in terms of another parameter t. Okay, for example, it can be like a particle is passing through a curve. A particle, some particle is passing through a curve, some curve. Okay? In a given time t, what would be its position in terms of x direction, in terms of y direction? Now substitute the t here, we'll get what is that x. Substitute t here, you will get what is that y. That x comma y point you will get. So that you will get the displacement. The displacement is what? Xi plus yj. R bar equal to xi plus yj in terms of vector notation. Okay. So in terms of vectors, R bar becomes xi bar plus yj bar. Now this is x is in terms of t, y also is in terms of t. Substitute that t, you will get that R bar, which is the displacement vector in terms of vector notation. And that's what introduce చేసేస్తాను. Okay, sir. Okay. Anyway, so but whatever it might be, so what is dy by dx here? What is dy by dx here? So if I have to find out what is dy by dx, first I need to find what is dx by dt here, and also dy by dt here, and then dy by dx is nothing but dy by dt by dx by dt. So whatever is dx by dt, find it out. Whatever is dy by dt, also find it out and take one over the other. You'll get the gradient, whatever is dy by dx. Okay, fine. Take a question. Find the differentiation of x equal to a into t minus sin t, y equal to a into 1 plus cos t. Geometrically, anyone knows what is this? If at all. I'm just throwing a question on you guys. Cycloid, correct. This is called as cycloid. How many cycloids we have? Okay. Anyway, cycloid. What is, you know what is a cycloid? Cycle తెలుసు ఈ ఆయిడ్లు కూడా అక్కడక్కడ పారాబోలాయిడ్ హైపర్బోలాయిడ్ వస్తాయి తెలుసు. వాట్ ఈస్ సైక్లాయిడ్ దెన్? ఓకే, cycloids 4 రకాలు ఉంటాయి. there are 4 types of cycloids. ఓకే, అండ్ యూ షుడ్ నో దెమ్. ఇది కూడా ఉంది, అందుకే చెప్తున్నా ఇది నేను. అయితే అన్నెసరీ టైం వేస్ట్ కదా. there are 4 types of cycloids. Instead of t, generally they write in terms of theta. Theta minus sin theta, y equal to a into 1 plus cos theta. This is one type of a cycloid. Okay, x equal to a into theta minus sin theta, y equal to a into 1 minus cos theta. This is another type of a cycloid. Next, x equal to a into theta plus sin theta, y equal to a into 1 minus cos theta. సరే, 1 ప్లస్ చేద్దాము. ఇది వన్ టైప్. x equal to a into theta plus sin theta, y equal to a into 1 minus cos theta. This is another type of a cycloid. There are 4 types of cycloids. Okay, now how does these cycloids look like? You always should know objects geometrically always. Even I was talking the other day, anything that you see somewhere, you should have the geometrical interpretation of that, geometrical visualization of that. Some of the basic things like this, if you know, then obviously you can easily understand how it looks like, and given question you will understand what kind of an answer you will be getting. Okay, now cycloid. Second variety. These are 4 cycloids. 4 cycloids. Now here, this is one arch of a cycloid, one arch only. But the cycloid is not just this one. If you look at this one, like this, like this, like this, like this, it keeps going. Even the left hand side also, it keeps going like this. That is a cycloid. Here also, this keeps going. In the case of this one, this, it keeps going. Multiple arches would be there in that cycloid. But if you look at one cycloid, okay, now out of these four, match the following. At one point of time, we used to have in prelims we used to have optional subject. Okay, we used to have optional subject in prelims exam till 2013. Okay, now in prelims, if you have optional subject, what happens? I used to have mathematics as my optional subject. MCQs, 4 diagrams, 4. Match the following. Match the following. A, B, C, D. Question, na? So we people just look at it and put the answer because we know all these objects. Now, why I am telling you this is important, you know the reason. If you go to calculus, okay, if you go to calculus, there are multiple questions that can be asked from single object. Okay, one thing is area. What is the area? What is the area included between one arch of the cycloid and x-axis? One arch of the cycloid, whatever, one of them would be this one, that expression would be given, and then one arch of the cycloid and x-axis. Okay, in this case the area would be this one. Okay, but what about in this case? The area would be this one. It's different. It's different. Okay, so unless you know what exactly is your cycloid, you will not be able to get the right answer. Second variety of question. This cycloid, I will rotate this cycloid about x-axis. Rotate this cycloid about x-axis. This is just one curve only. If I rotate this cycloid about x-axis, what happens? It sweeps an object. Or, I would rather say one thing. The area included between the cycloid curve and x-axis, the area included between the curve, one arch of the curve and x-axis, what would be that area? This one. This area is rotated about x-axis for 360 degrees. Now what happens? This area sweeps certain volume. You will get a three-dimensional object. What is the volume of that three-dimensional object? That can be a question. Or what is the surface area of that three-dimensional object? Getting my point? For this and this, you will get similar answers. But this and this, you will get different answers. Are you getting that? So, it's always important for you that any given expressions, if at all there are standard expressions, you should definitely know their visualization. How do these objects look like? Okay? Got it? Sir. ఇంటికెళ్ళి చేసుకుంటారు ఇది చేయగలరా లేదా చెప్పాలా this is obvious, this is x and this is y. Okay, this point obviously is 0 comma 0. That point is obviously is 0 comma 0. Okay, passing through 0 comma 0 there are only two curves here, so this also is 0 comma 0. The other two does not pass through origin. Suppose when I put t equal to 0 or theta equal to 0, somewhere I kept theta equal to 0. Now what happens? 0, sin 0, 0, 0, x equal to 0. Cos 0, 1. Okay, 1 plus 1, 2. 2a, y equal to 2a. That means at theta equal to 0, this curve passes through 0 comma 2a. So this is 2a basically. The height is 2a here. This also is 2a. Okay, that means that this particular cycloid can be either this one or this one. Either this one or that one. Okay. Now suppose t equal to 180 degrees. pi. Theta equal to pi. Okay. Now theta equal to pi means sin pi 0. Theta equal to pi a pi, x equal to a pi. Theta equal to pi cos 180 minus 1, y equal to 0. That means at pi, theta equal to pi, this curve passes through a pi comma 0. Theta equal to pi, it passes through a pi comma 0. A pi comma 0, what is that? Where is that? This would be a pi. X equal to a pi, y equal to 0. This equal to a pi, y equal to 0. Okay, got it? Now what is the difference now? How to identify between these two? Look at that one only. Where does we land up? How do you know this one and that one? This actually goes to minus a pi also. Now see where minus a pi is. See where minus a pi is. Okay? Theta equal to minus pi. Theta equal to substitute minus pi. You'll get it. So the objective of knowing all these four along with all these four curves is that you exactly need to know which one is for what. This is for what, this is for. The match the following must be there for you. Without match the following, if at all any, in advanced integral calculus, if at all any question is expected, then it would be somewhere here. Okay, I am not moving further because it's waste of time in this context. Okay, anyway, what is the differentiation then? dx by dt you have to find out, as well as dy by dt you have to find out. What is dx by dt? A into 1 minus cos t. What is dy by dt? Minus a sin t. Then dy by dx is nothing but minus a sin t by a into 1 minus cos t. Can you further simplify this? Can you further simplify this? This is equal to a gets cancelled anyway, minus sin t, I can write it as 2 sin t by 2 cos t by 2. Then what is 1 minus cos t? ఇందాక ఎక్కడ రాసాం కదా, అక్కడ రాసాం కదా తుడిపేసి. What is 1 minus cos t? In terms of sin t by 2 and cos t by 2, if at all you want to write. Sin t by 2, sin or cos? What is cos 2 theta? మళ్ళీ మర్చిపోయారు. What is 1 minus cos 2 theta? Is nothing but same thing here also. So this comes out to be 2 sin square t by 2. 2 gets cancelled, 1 sin t gets cancelled, minus cot t by 2. So that simplification also is important. Sometimes from here you need to go to here, from here we need to come to here. So it all depends upon what you are going to do or what kind of question that is. Okay, fine. This is parametric notations. So many questions are there in parametric. You can go home and try to solve them. Okay, one more in differentiation, logarithmic differentiations. Logarithmic. Suppose I have something like logarithmic. Suppose I have something like y equal to f of x whole power g of x. Y equal to f of x whole power g of x. So the best way of differentiating this is taking logarithm on both sides. Log y equal to log of this entire thing, which is nothing but g of x log of f of x. Now if I differentiate, log y differentiation is 1 by y dy by dx is equal to uv here, g of x into differentiation of this 1 by f of x into f dash of x, where f dash of x is df by dx, okay, plus g dash of x into log of f of x, g dash of x into log of f of x, okay, fine. అంటే ఇవన్నీ మనకు తెలియనివేం కాదు, బట్ చేయాలి. Something like y equal to ఇట్లా చేద్దాము, x power y suppose, just like that ఇచ్చాను, ఇక్కడ ఏం లేదు కానీ ఇచ్చాను సింపుల్గా రావటం. ఓకే, సపోజ్ y equal to x power y, then find dy by dx. Okay, find dy by dx. So what we'll do, take logarithm on both sides is equal to y log x. Now differentiation 1 by y dy by dx is equal to, or maybe y dash, whatever, so dy by dx into differentiation of log x is 1 by x plus, sorry, dy by dx into log x plus y into 1 by x. Now take dy by dx common here, and then whatever comes, bring it to other side. Okay, fine. So that's all when it comes to differentials. Inkem varieties. So same thing. One more question. X power y equal to e power x minus y. X power y equal to e power x minus y. Again, take logarithm on both sides and then try to do that. Ivanni got a regular ones. Okay. Fine. That's about differentials. Now let us come to integrals. So I am trying to only work on those kind of differentials or integrals which are useful for us. So there are so many other varieties which I don't think so are required in our kind of problems, civil services variety problems. Okay. So integrals, again, you have so many formulas that are given. So many formulas. So integral of 1 equal to x, or integral of x power n equal to x power n plus 1 by n plus 1 when n not equal to minus 1. Integral of 1 by x is log x. Integral of e power x is e power x itself, blah 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 blah. So integrals, one important formula is integral of u into v, where u and v are both functions of x's. Okay, what is this? So u into integral of v minus integral of differentiation of u into integral of v. Is that okay? మర్చిపోయామా? తప్ప? కరెక్టా? రాంగా? We forgot it, right? Correct na? Is it okay? Understood? So integral of u a function of x, v also is a function of x, dx equal to u into first term into integration of v, second term, minus, this is minus, okay? Don't put it as plus, it is minus. Integral of the first term differentiation and the whatever the integral of this one. Okay, now the point is, here again there are two more terms. This also looks like integral of two terms. Integral of UV style again. So that again can be written in terms of same formula. Again you will get two more terms. So it keeps repeating. Therefore there is something called as a chain rule here. Chain rule. What is this chain rule? Chain rule of UV. Dx would be there anyway. Okay. Chain rule of UV is U into integral of V. I will write it as V1. V1 is first integral of V minus differentiation of U double integral of V. V2 is double integral plus U double dash triple integral minus U triple dash fourth integral plus so and so and so. It goes like this. This is integral of UV chain rule. Chain rule. Important. Important. Okay? Important. One example I will give you. So we already know that e power x integral, dx would be there anyway, is e power x. And remember, whenever you write an integral plus integration constant, you have to always write. Don't forget writing that. And whenever you do this in the final exam, in your answer, since you introduced a new term here C, you have to mention where C is an integration constant. You have to write this. Where C is an integration constant in your answers, because it's a descriptive answer style, right? Okay, so you have to always, when whatever you introduce, you always have to mention that it is an integration constant or whatever it is. Let it be anything, C1, C2, C3, whatever you introduce. Okay, you have to mention what it is, integration constant. Okay. Anyway, as far as we are concerned right now, since we are more concerned about the formulas, right? Okay, so I will not write every time C. Now, let us look into this one. Integral of x e power x. Integral of x e power x. Okay. One is u, other is v. U, v. So u into integral of e power x. E power x minus integral of differential of u, which is 1. Integral of e power x is e power x dx, which is equal to x e power x minus integral of e power x is e power x itself, plus c would be there. So which is nothing but x minus 1 into e power x. Okay. Same thing, let us try to apply chain rule. Let us try to apply chain rule. Okay? Chain rule. Integral x e power x dx is equal to chain rule. X into u. U into integral of e power x minus. What next? Differential of first term u dash. U dash is 1. V2, 2 times integration of e power x, again is e power x, which is x minus 1 into e power x. Okay? Now the best part of e power x, whenever e power x is part of your, one of the product terms here in integrals, one of the product terms, the best part would be x into e power x dx. You have a shortcut. Always take e power x common. Whatever the function of x, always algebraic functions only. I am talking about algebraic functions. For example, x power n. Algebraic function x power n. E power x take common. Whatever the function x power n, put x power n minus differentiation of x power n into x power n minus 1 plus differentiation of this one n into n minus 1 into x power n minus 2 minus differentiation of this one n into n minus 1 into n minus 2 into x power n minus 3 plus so and so, minus so and so, plus so and so. Somewhere it will stop. Because after n differentials, n plus 1th differential becomes constant, 0. So it means that suppose I have x square e power x is there. X square e power x. Then take e power x common. Bracket x square minus differentiation of x square 2x plus differentiation of 2x 2. That's it. After that it's 0. Suppose x cube e power x dx is equal to e power x into x cube minus differentiation of x cube 3x square plus differentiation of 3x square 6x minus differentiation of 6x 6. That's it. Remember this one again. This keeps coming in your integrals. Okay? In ordinary differential equations, especially this one keeps coming. Regular it keeps coming. So at that point of time, just look at this and write this one. That's it. Don't go with the formula again. Don't go with this formula or this formula. Don't go with these formulas. These formulas anyway there. But based on these formulae, we already got certain shortcuts. Then these are shortcuts. You have to remember. Suppose instead of e power plus x, you have e power minus x. Instead of e power plus x, you have e power minus x. So integral e power minus x dx is minus e power minus x plus c, or integral x e power minus x. X e power minus x. X into, chain rule, x into e power minus x by minus 1 minus differential of x 1 into integral of this entire thing e power minus x by minus 1 into minus 1 plus 1, which comes out to be this also minus, this also minus, minus e power minus x taken common, x plus 1. So in the case of e power minus x, take minus e power minus x as common and write whatever is f of x here plus differential of this plus differential plus differential. So if it is x cube e power minus x dx, this is minus e power minus x into minus e power minus x into x cube plus 3x square plus 6x plus 6 plus 6. Okay? This keep coming in your integrals, in our kind of questions especially. Okay. So chain rule is done. Of course, in integrals there are most of the times you go with substitutions. So find the integral of anything. Find the integral of suppose x tan inverse x by 1 plus x square whole power 3 by 2. You know? What to do? Substitution. Substitution of what? Put x equal to tan t or tan theta, whatever. Okay? So dx comes out to be equal to secant square theta d theta. So integral of this, x is tan theta, tan inverse x is theta divided by 1 plus tan square theta is secant square theta. So secant cube theta dx is secant square theta d theta. Secant square theta d theta. Okay? Till now okay, right? Simple thing, not such a So secant square gets cancelled. One secant is there. One secant is, in fact, denominator 1 by cos theta. Here sin theta by cos theta is there. Therefore sin theta remains theta sin theta. Theta sin theta. Okay? UV rule. Theta into integral of sin theta minus cos theta minus differentiation of theta 1 and integration of minus cos theta. Integration of minus cos theta is, integration of cos theta is what? Sin theta. Minus cos theta integral is minus sin theta. So minus sin theta, which should be minus theta cos theta plus sin theta. Now you cannot stop here, you have to come back. You have to come back with x's. Transform all these thetas into x's. So what is this? Theta is tan inverse x. Cos theta is Yaradna? So cos theta is basically 1 by secant theta. Or ఇంకెట్ రాయొచ్చు సీకెంట్ థీటా వస్తే అక్కడ tan theta రావాలి మనకి 1 by root of 1 plus x square. Okay, so what you are trying to tell is 1 by secant theta, 1 by root of secant square theta. Secant square theta is 1 plus tan square theta. Okay, so 1 by root of 1 plus x square. 1 by root of 1 plus x square plus sin theta now. X by root of 1 plus x square. X is tan theta divided by root of 1 plus tan square theta is root of 1 plus tan square theta is root of secant square theta. Root of secant square theta is secant theta. Tan theta by secant theta is sin theta. That's what we got, sin theta, right? Tan theta by secant theta is sin theta. So you have to convert back always. Okay? See, in UPSC, unless otherwise, it becomes very difficult for you to transform it back. Unless otherwise, it is very difficult to transform it back. You will keep it as thetas only. Okay? Because the evaluator will have his final answer in terms of x's, not in terms of thetas. Because theta is something which you have taken. You have taken it as x equal tan theta. Someone else would have taken 1 plus x square is equal to t square. Someone would have done something like that. Okay? So for him, that t would be different. For you, this theta is different. Okay? Anyway. So many examples, okay? You can solve these examples at home. Anyway, I'll give you a soft copy of this. Another variety, it keeps coming. So 1 plus x square by 1 plus x power 4 dx. ఇంకొక రెండు మోడల్స్ ఉంటాయి ఇంటిగ్రేషన్లో which I want you guys to know. After that, I will go to 2D geometry. Yeah. Any idea? On x square? X square whole square. Then put x square equal to t. X square equal to tan theta. Okay. So x square equal to tan theta. Then 2x dx equal to secant square theta d theta. And then I will tell you another technique here. Okay. Which will take a right? Okay. Different ఆలోచిస్తే ఇట్లా వస్తుంది. I will take x square common in both numerator and denominator also. Okay? అదే నన్ను చెప్తుంది? Not that one. Okay. So I will take x square common in numerator as well as denominator also, which cancels off that x square, which gives me 1 by x square plus 1 in the numerator divided by 1 by x square plus x square in the denominator. Okay, ఇంకా unnecessary complicate చేస్తున్నామా? This is equal to integral of, okay, we'll leave like this. Look at denominator. One minus 1 by x square, 1 plus 1 by x square. I'm just trying to see what is there in the numerator. The integration of this I am looking at basically. Now, of course, the term which on differentiation gives me this one, which is x minus 1 by x. Okay, 1 plus 1 by x square. Okay, whole square. Now see, x square plus 1 by x whole square minus 2. Okay, minus 2, so I'll put plus 2. Okay, now put x minus 1 by x equal to t. Put x minus 1 by x equal to t. This gives me numerator is dt by t square plus 2. dt by t square plus 2. Is that okay? So 1 by 1 a square plus x square. 1 by a square plus x square formula, integral 1 by x square plus a square formula. ఏంటి ఫార్ములా అడుగుతున్నా? One by a tan inverse. Integral 1 by a square plus x square or x square plus a square is 1 by a tan inverse x by a. 1 by a tan inverse x by a. So this is equal to 1 by a. What is a? 1 by root. A is root 2, 1 by root 2. Tan inverse t by root 2. And what is t? This one. That's it. Another way of doing things, not that this is the only way. Okay, like this there will be so many varieties. Just keep doing the homework that I have given you, so many. Okay, so one more, partial fractions. This is very important. Okay, till now. This partial fractions is very, very important as far as we are concerned, because most of the times when you solve a differential equation, you will get some of these integrals. Along with that, you might require to integrate something like this. Integral of, maybe you have something like x plus 1 into x plus 2, suppose. A simple one. Okay, f of x is 1 by x plus 1 into x plus 2. Now this whatever 1 by x plus 1 into x plus 2, you convert into partial fractions. Some a by x plus 1 plus b by x plus 2 dx. What is that a and what is that b? How do you find? To find this a, the shortcut is, of course, you can both of them equate and find a, b values, but there is a shortcut. Every time you cannot spend so much time on equating both of them and trying to find the values of a and b. No. So in order to get the numerator of x plus 1, this is a term which is x plus 1, right? So I'm just putting this as 1 here, dx I will put it here for our convenience. Okay. So in order to get the value of a, first you close the corresponding term here. So what remains is 1 by x plus 2, and substitute x equal to minus 1, because x plus 1 is here, in order to find the numerator of this, close this x plus 1 here and substitute x equal to minus 1. So minus 1 plus 2 is plus 1, 1 by plus 1 is 1. So a is 1 here. ఎంత తీసేద్దాం. This is A. Okay. Generally, how would we solve this is, look at the numerators. Okay. Denominator here, this, if I try to simplify this one, this becomes A into x plus 2 plus B into x plus 1 by x plus 1 into x plus 2. That's how it is, right? Comparing these two, what happens? 1 equal to A into x plus 2 plus B into x plus 1. That's what it is. Okay. Now, in order to find the value of A, one way of doing things is, this you put it as ax plus bx plus 2a plus b and equate it to 1. So there are no x terms in the left hand side. Therefore, ax plus bx or a plus b into x should become 0. That means a plus b should become 0. That is one thing. A plus b equal to 0. Similarly, 2a plus b has to become equal to 2a plus b has to become equal to 1. Now you need to simplify all these things and get the values of a and b, which I am going to substitute here. That's the general procedure. If it is a plus 2 level guy, he will be doing like that in the examination. He will be given 10 marks or something like that. Okay, in our case it's not like that. So one way of doing this is, you don't need to even do all these things. From here itself I can work it out. Okay, look at this. If I substitute x equal to minus 2, what happens? If I substitute x equal to minus 2, what happens? This becomes 0. Here minus 2 plus 1 is minus 1, minus b equal to 1. So b comes out to be equal to minus 1. Got it? Or I will put x equal to minus 1, which gives me this as 0. Here x equal to minus 1 is minus 1 plus 2 is plus 1. A equal to 1. A equal to 1. Got it? So directly you will get it from here. So if you want, you can verify a plus b equal to 0, 2a plus b equal to 1. It's verified. Another technique, you don't need to do even all these things. From here itself you can get the answer. How to do that? That is something like this. So what you have to do is, if I need to get a, that is which is the numerator of x plus 1, then left hand side close x plus 1 and substitute x equal to minus 1. Put x equal to minus 1, minus 1 plus 2 is 1, 1 by 1 which is 1, equal to 1. Now in order to get b, which is numerator of x plus 2 numerator, close x plus 2 here, close x plus 2, okay, and substitute x equal to minus 2, substitute x equal to minus 2, minus 2 plus 1 is minus 1, 1 by minus 1 is minus 1. Look at this. That means in the examination hall, you don't have that enough time or liberty of doing all these things. Don't do that. Don't do that mistake of doing all those things. Directly you write like this. For example, this is integral dx. So you will write integral dx. That's it. Directly you will write this step. You don't write any of these steps. Save your time always. Okay. Now from this, the integral would be obviously 1 by x plus 1 integral is log of x plus 1 minus log of x plus 2 plus c. That's it. Understood or not? So this partial fractions really plays very, very important role in your integrations. Okay. Okay. Suppose assuming that numerator you have some x plus 3 is there. I'm just giving another example. Numerator you have x plus 3 is there. Now these terms would change now. Okay. You tell me what should be the numerator of x plus 1. Numerator of x plus 1 means first close this one. Okay. Put x equal to minus 1. Minus 1 plus 3 is 2 divided by minus 1 plus 2 is minus 1 plus 2 is plus 1. So this is 2. Numerator of x plus 2. So close x plus 2, substitute x equal to minus 2. Minus 2 plus 3 is plus 1 divided by minus 2 plus 1 is minus 1. Therefore minus 1. That's it. Close. Done. Okay. So these kind of shortcut techniques you should always know. You cannot say that all these things I will do in the examination. You don't have that much space also to write an answer, and that much of time definitely is not available. Okay. Fine. One more similar kind of a thing. For your consumption, x square plus 1 by x square plus 2 into x square plus 3 dx. Same thing. See, we are least bothered what is that x square. It looks like t plus 1 by t plus 2 into t plus 3. That's it. So this is nothing but here x square plus 2, here x square plus 3. In order to find numerator of x square plus 2, put x square equal to minus 2. Minus 2 plus 1, minus 1 by minus 2 plus 3. Minus 2 plus 1, minus 1 by plus 1, which is minus. Now x square plus 3 numerator. Close this. Put x square equal to minus 3, minus 2 by minus 1 plus 2. That's it. Close. Got it? Okay. Another one I will give, because another variety of partial fractions. Integral maybe suppose dx by x plus 1 whole square. Of course, this is easy one anyway. So into x plus 2 also I will put, numerator I will put x plus 3. I am trying to complicate, that's it. Okay. Now always remember one thing, whenever you have square terms here, square or cube terms, you will get extra term in your right hand side. This is nothing but a by x plus 1 plus b by x plus 1 whole square plus c by x plus 2. This is how you have to write the partial fractions. This is how you have to write the partial fractions. Is that clear? Okay. Now there are three things that you need to find out now. Okay. Now first, in order to find what is the numerator of x plus 1 or x plus 1 whole square or x plus 2. X plus 2 is easy here because only unique term is x plus 2. So close x plus 2 and substitute x equal to minus 2. 1 by 1. This is plus 1. This is 1. That's it. Got it? Okay. Now what next? If I close, but this is x plus 1 whole square, therefore x plus 1 whole square term is something which I am looking at when I substitute x equal to minus 1. Put x equal to minus 1, 2 by plus 1. So this is 2. This term is 2, but what about x plus 1? Numerator. Arayara. 2. Why? A equal to 2 you are saying? A equal to 2. 2, number 2. Okay, how?
I am assuming both part and both. X plus 1, x plus 2.
X plus 1 and x plus 2? I'll tell very, very simple technique. This is not there, okay? We are talking only partial fraction. Simplest thing. This entire thing, put x equal to 0. It should match or not? Put x equal to 0. What happens? 3 by 1 into 2. 2. X equal to 0. A plus x equal to 0. 2 plus x equal to 0. 1 by 2. Got A. What is that? Why only x equals 0? You can put x equal to plus 1, plus 2, plus 3, which is different from minus 1 and minus 2. You can, any value of x which is different from minus 1 and minus 2, you can always keep. Getting my point? Okay? So simplify things always. Always identify the simplest way of solving these kind of things. You should not waste your time here. The idea is you are not supposed to waste your time. Got it? Okay. So some more varieties of partial fractions, you can find them in the handout which I am going to provide it to you guys. And one last variety we'll discuss, because that is something which is just ticking my mind, that would definitely come in your questions. Where is that model? These are all partial fractions. I want the root ones, multiple factors. Oh, these things formulas are the integral 1 by root of a square minus x square, square root of a square minus x square, all those stuff anyway you have them there. Yeah, got it. Okay, let us look at this question. Integral of x by x minus 3 to root of x plus 1. Okay? Ideas? What's the best way of doing this one? Everything we have done on our plus 2 level itself. These are all plus 2 level. But this integral is important for us, therefore I am putting it here. Put obviously x plus 1 equal to t square. Put x plus 1 equal to t square. It gives me dx equal to 2t dt. Okay? So our integral becomes x is t square minus 1 divided by x minus 3. X minus 3 is what? T square minus 4, because t square is x plus 1, minus 4 is minus 3, and then root of x plus 1 in t square, this becomes t dx equal to 2t dt. Is that okay? All? So tt gets cancelled, 2 remains. Integral t square minus 1 by t square minus 4 t plus 2 into t minus 2 dt. Partial fractions. Partial fractions. Got it? Partial fractions. That's it. Or if you are very good at integrals, one more thing you can also do. This is a partial fractions, easy one. Or else what you can do is to numerator you write it as t square minus 4 style. Minus 3 plus 3. So t square minus 4 already there in the denominator. T square minus 4, which is 1, plus 3 by t square minus 4 dt. Okay? But you should know what is the integral of 1 by x square minus a square. It is there. 1 by 2a log of x plus a by x minus a, whatever, we will get it. Understood? This is one variety where you will put the square root term x plus 1 equal to t square. There would be another variety also. Just hold on. Just hold on. to 1 by 2. Okay, take this one. Another one. Because this also is important because one of the questions will get this one. Integral 1 by x plus 1 into root of 2x square plus 3x plus 4 dx. One of the questions I have seen, of course there are one of the models, okay. If you know this one, it becomes easy later. Okay, there is a difference between this and that. Here, had this been maybe x square plus 1, the square root term is x square plus 1, okay, higher degree, then it looks like that. In that case, in this case we have kept x plus 1 equal to t square, but in other variety you have to put, any idea? 1 by t. 1 by t. Put x plus 1 equal to 1 by t. This is important. Okay. Now what happens? This also implies dx is equal to minus 1 by t square dt. Okay. This gives me the integral as 1 by x plus 1 is 1 by t root of. Okay. Now what? X square is 2 times of 1 by t minus 1 whole square plus 3 times of 1 by t minus 1 plus 4 inside the square root. Dx into minus 1 by t square dt. Little bit complicated, but yes, we have these kind of questions. That's the reason I am trying to cover this. This is called integral. Okay. From here, in the denominator of the denominator, you will get in the square root 1t comes out, t square. Okay. If you take the LCM, 1t comes out, 1 by t square, 1 by t square, they get cancelled. Minus 1 by square root of 2 into 1 minus t whole square plus 3 into 1 minus t plus 1 minus t into t plus 4t square dt. Okay, and then you need to simplify it further. Minus integral 1 by 2 into 1 plus t square minus 2t plus square root of, okay, plus the 3t minus 3t square plus 4t square, whatever, dt. And then whatever you get in the square roots will be there. Whatever you get, based on that you have to solve it. Okay? Anyway. Okay, we'll do one thing. This comes out to be, because let me complete this one. Square root of 3t square minus t plus 2. Okay, fine. How do you solve this? How do we solve that? Factors. 3t squares. Factors చేసేద్దామా? ఫ్యాక్టర్స్ చేస్తే డినామినేటర్లో స్క్వేర్ రూట్లో ఉంటాయి ఫ్యాక్టర్స్. We can convert this into 1 by root of a square minus x square or 1 by root of x square minus a square format.
Roots imaginary or roots real?
దాన్ని బట్టి మీకు సైన్ ఇన్వర్సా సి లాగరిథంలో లాగ్ ఆఫ్ x plus root of a square minus x square at loss. X square minus a square. Hyperbolic loss. So in order to get into these kind of things, look at this. Is equal to minus integral 1 by. Okay. Take 3 common. So by root 3. Okay. Square root of t square minus t by 3 plus 2 by 3. This is called minus 1 by root 3 integral 1 by dt ఉంటుంది. Square root of t minus 1 by 6 whole square. See, t square minus 2ab minus 2 into t into 1 by 6 minus t by 6. Sorry, minus t by 3. Minus t by 3. These two are covered. Plus 1 by 36 is there. But what we need to have, minus 1 by 36, I need to add 2 by 3. Minus 1 by 36. Is that okay? 2 by 3 anyway should be there. Since I added 1 by 36, I need to subtract 1 by 36. Okay? So it gives me 12 to 24 minus 1, 23 by 36. 23 by 36. This is in the form of 1 by root of some t square plus a square time. Can you see that? This entire thing is t square plus this entire thing is a square. Apply the corresponding formula. Now very few questions are of this variety, but we should know it. That's the idea. Okay? Fine. Okay, that's it. That's about integrals. A very few minutes I will spend on 2D geometry as well. Okay, na? Okay, so certain basics of 2D geometry. Okay, 2D geometry. So first thing in 2D geometry is straight line. So straight line, what you should know here, there are different forms in which you can write a straight line. The equations like ax plus by plus c equal to 0. This is also called as general form. General form of a straight line. Okay? Y equal to mx plus c is slope intercept form. Slope intercept form. Slope is m, intercept. Y intercept is c. Okay? And then x by a plus y by b equal to 1 intercept form. Intercept form where a is x intercept, b is y intercept. Okay? That's it. You don't need to know much beyond that. Okay? Rest of the things we will work it out. 2. Pair of straight lines. Pair of straight lines. Okay? Now ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Pair of straight lines means a straight line like this, another straight line like this, they multiplied together is a second degree equation. If that second degree equation looks in the form of this one, ax square plus 2hx5 plus by square plus 2gx plus 2fy plus c equal to 0, those two are pair of straight lines. Okay? If this has to represent pair of straight lines, then delta, there is something called as delta, should become equal to 0. What is the delta? What is the delta? The delta is, anyone? What is the delta? Formula? Slope? No, it's not slope. Two straight lines, parallel or intersecting straight lines, whatever. It's a product of these two straight lines. See, every straight line has its own slope. Okay? So the delta is not slope. Some expression. What is that expression? ABC plus 2FGH minus AF square minus BG square minus CH square. If that becomes equal to 0, then we call that expression represents pair of straight lines. Pair of straight lines. Okay? It's gone already, way back, right? Refresh yourself. Remember this, it's important. Okay, it's important. If it's not important, I would not have covered this here in this class. You should know this. Okay? Next. If it is difficult for you to remember this one, this is also a determinant. A, H, G, H, B, F, G, F, C. It's nothing but the same determinant. The determinant of this gives me that one. Okay? You have to remember, there is no other way out. You cannot say that, no sir, I cannot remember. I am sorry. Okay? So the angle between them, theta is equal to tan inverse, because there are two straight lines. If they are parallel, it's okay. If they are not parallel in 2D geometry, the two straight lines are not parallel, they definitely have to intersect. There is no other way out. 3-dimensional is a different story. We have another scenario. Okay, in 3-dimensional geometry, what happens? Two straight lines can be parallel, can be intersecting, can be skew also, like this. 3-dimensional geometry. These we call them as skew lines in 3D geometry. But 2D geometry, we have only two scenarios, parallel or intersecting. That's it. So the angle between them is always given by tan inverse of root of h square minus ab by a plus b. H square minus ab by a plus b. See, these AHB, these are the only three terms which define your slope of those two straight lines. Okay? Not these terms. Those terms would be something else. Okay. So if a plus b equal to 0, then what happens? Tan inverse infinity, which is tan inverse infinity, 90 degrees. That means these two, the straight lines given by this equation, those two straight lines are intersecting at 90 degrees. Okay? Okay, fine. Third one. Circle. Circle. So the general equation of a circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. For a circle, there are certain basic things. The coefficient of x square and y square have to be same, and there should not be any x into y term. This term should be missing. H is equal to 0 always for a circle. Okay? Anyway, this is also called as general form. Next, x minus a whole square plus y minus b whole square equal to r square, where the center is a comma b and the radius is r, obviously. Okay, in this case what would be the center? Minus g minus f is the center and radius is square root of g square plus f square minus c. Okay na? అంటే మర్చిపోయి ఉంటాము, బట్ గుర్తుపెట్టుకోవాలి కూడా. If you don't remember these things, we cannot even, not even single step you can take forward. Okay, very important. Okay, these are circles. So we have pair of circles also. Pair of circles generally would be like two circles. It can be like this, or it can be like they are touching each other, or they might be intersecting circles, or there might be a circle which is inside another one, or a circle which is like this. So varieties would be there. That's okay. So that's not a big thing. When it comes to circles, we have tangent lines of the circle. How to express a tangent line? Suppose there is a point here which is x1 comma y1. The circle equation is this one. Okay, we call sometimes circle as like this, S, we represent it. Okay, now the tangent line here would be something like this. This in fact is nothing but S1 equal to 0. S1 means what? Xx1 plus this is equation of tangent line. Okay, గుర్తుండాలి అది కూడా, అందుకే చెప్తా. You need to remember this also. So there's something else also which when we come to this part we can discuss that one. That's not an issue. Anyway, let me cover that ellipses, parabolas and hyperbolas as well. Conics. Conics. What are conics? What are conics? Sometimes people also call it conic section. Conic section. So in the conic section we have ellipse, parabola and hyperbola. Ellipse, parabola and hyperbola. Okay, so why we call them as conic sections? Why we call them as conics or conic section? It's nothing but if you take any right circular cone when it is sectioned by a plane, different ways that you can section the cone, different surfaces are formed. Each of the surface represents one of them. Even circle also is a conic section, for your kind information. For example, suppose I have a cone like this. This is circle here. Okay, it's a circular cone. It's a right circular cone. Suppose this is a base in fact will be in a plane. Base would be in a plane. Okay, for example, this is a cone. This is a plane, suppose. Okay, right circular cone. Okay, plane, it's a circle. Okay, parallel to the plane, if I intersect this cone, so I consider another plane which intersects this parallel to the base circle, intersects it. What we get here is what? Circle. The center of the circle would be on this axis Now if that is origin, suppose it looks like x square plus y square equal to r square. Okay. Now instead of like this, if I intersect this like this, inclined to the axis, okay, here it is that what I get is an ellipse. It looks like x square by a square plus y square by b square equal to 1. Okay, x square by a square plus y square by b square equal to 1. Now there is another section also. Parallel to this slanting line, if I intersect it, what I am going to get is called as a parabola. Parabola looks like y square equal to 4ax. This is parallel to the slanting line. Instead, there is another final section which is parallel to the axis. If I intersect, I'll get something called as a hyperbola. It looks like x square by a square minus y square by b square equal to 1. X square by a square minus y square by b square equal to 1. Okay, circle, you know, ellipse, x square by a square plus y square by b square equal to 1. This length is a, this is b. Okay, now the ellipse has something like called as, there are 2 points here. These are called as, suppose A and B, these are called as foci. It has got its own properties. Okay, I am not going deeper into those properties. And this 2A is called major axis. 2B is called as minor axis. They are also called as principal axis, which are major axis and minor axis. Okay. And there is something called as a directrix here. Okay. ఇంకేమున్నాయి? బాబు వస్తున్నాయి. Okay, this is ellipse. Let us go to parabola. See, how do ellipses form? Inclined to the plane, the base plane. Okay, so that we'll get this kind of a section. Parabola looks like y square equal to 4ax. It looks like this. This is y square equal to 4x. It also has got a focus. This has 2, therefore I call foci. So it has got only one focus. This is y square equal to 4ax. Okay, this distance is a. There is one length here, we call it as latus rectum. Okay, so this is a comma 2a. This point would be a comma minus 2a. This obviously is 0 comma 0. There is one called as directrix here. This directrix would be x plus a equal to 0. This is 0, right? So this also is a. So at a distance of minus a units, x equal to minus a is a vertical line. So x plus a equal to 0 is the directrix. Okay? This is standard now. So this curve which is like this, okay, if it is rotated like this, it becomes x square equal to 4ay. Again, all this entire thing 90 degrees rotated. X square equal to 4ay now, instead of y square equal to 4ax. Okay? Another rotation you can always have. Even instead of 0 comma 0, you can have h comma k as this point. Vertex, we call this as vertex. Vertex can be translated to h comma k, in which case y minus k whole square equal to 4a into x minus h. It would become. Translation happened. Okay? This is what is parabola. And then hyperbola. Hyperbola is what? X square by a square minus y square by b square equal to 1. It would be something like this. One year, another year like this. This is a, this is a. It has focus, it also has a focus. Okay? 2 years. Now, but if you see here in this cone, this line, this is the line which gives hyperbola, right? This line, you can see, this line intersects the cone here. This intersection gives me this year. 2 years, 1 year. How do we get this? Here gives another one. No. There are so many like this, na? Cone, na? We can. No, not all. Up there is another one. Cone is not just this one. The wrong assumption that we have on cone is that we always feel that cone is only this one is cone. No. Cone actually extends like this. Cone actually extends like this. This plane also intersects this one also. Got it? Now we have 1 year, another year here. This is entire cone. This is entire cone. Cone is not only the bottom one. This one also is the cone. It's not even extension of the cone. That is part of the cone. Because you know what is the definition of cone? The definition of cone is, it is locus of a straight line. Locus of a straight line in 3 dimensions. Imagine this in 3 dimensions. Imagine this in 3 dimensions. It's a straight line. That straight line keeps moving straight line. So locus of a straight line I am talking. Locus of a straight line passing through a fixed point. Locus of a straight line passing through a fixed point. And also passing through another curve. For example, straight line passing through a fixed point and also passing through another curve here. So base I have some curve. I have a fixed point. So I have a straight line passing through fixed point and also this curve. This is called base curve. Okay. Now this line passing through the fixed point, this is fixed here, the line is moving. How is it moving? It is moving along the passing through this curve. If suppose this curve is a circle, then you will get a circular cone. If this curve is an ellipse, you will get an elliptic cone like this. Getting that? But if you see, the straight line not only is up to here, it also extends. No? Straight line is not only up to here, up to this point. The straight line extends to infinity in that direction, infinity in this direction. Therefore, the cone here goes to infinity like this. and also infinity like this, because it's a locus of a straight line. It's a locus of a straight line. Therefore, it extends to infinity that direction as well as this direction. So the name of the cone is always named based on the base curve. Base curve. If this base curve is a circle, you will get a circular cone. Base curve is an ellipse, you will get elliptic cone. Parabola, then parabolic cone. Hyperbola, then hyperbolic cone. That's it. Got it? So cone means you always have this part also is part of our regular cone only. It is not like an extension of this one. No, it's there already. But all these years we never saw that one, because we don't know definition of cone. Okay, that's okay. Now you understood, right? That's how the hyperbola has got the second year. Got it? And what is principal axis? There is something called as principal axis. Coordinate axis everyone knows. X axis and Y axis is the coordinate axis. And what is the principal axis of a cone? Here if you look at this major axis, minor axis is the principal axis. Because the principal axis might not always coincide with the coordinate axis. The principal axis, I can rotate this one, entire image. Then my principal axis of this ellipse is different from coordinate axis. Okay, might be that this entire thing I will shift to some other place. Instead of 0, 0, I will shift to some h, k, in which case my principal axis is different from coordinate axis. Okay, but this expression, the principal axis is exactly coinciding with the coordinate axis. Here also the principal axis exactly coinciding with the coordinate axis. So all these conics has a principal axis. Got it? That's it. Tangents and all those stuff, again is the same thing. S1 equal to 0 is a tangent on this. Got it? Any more questions? Done? Now I will come to the important announcement kind of. Okay. The thing is, I cannot start a full-time batch this year. Not possible for me. Okay. So I cannot have every day afternoon taking classes from 2:30 to 5 o'clock, which is not a possibility for me. Okay. So what I planned is two things. Okay. One is, I'll go with mentorship. If at all you people want mentorship from me. But in order to have this mentorship, one thing is the second part comes. The one thing is you need to have already attended the classes. Then it becomes easy for me to go with the mentorship. Or else what happens is, for everyone I have to teach everything again. Instead of I would have actually taken the classes itself. So point is, I cannot start a batch. Okay. Two is, if you guys go with my classes and other teachers also, we have, it's not like only someone was asking like whether I will be taking all the classes. No, I will, out of 13 topics, general I take 9 topics. Another teacher takes physics related topics are taken by another teacher, and there are another 2 more teachers who take up abstract algebra and real analysis. Okay. So there are altogether 4 teachers. Most of the topics generally I take. So last year classes, whatever are there, all are recorded. You can actually go for those recorded classes. And I'll give you very huge discount on those classes. Generally that would be the same price as that of regular classes, 40,000. But that I'll ensure that I'll give at a very, very moderate cost. So you just attend all those lectures one after the other. I will give you the sequence. I will give you every week what you have to do. Every week 1, 2, 3, 4, 5, 6 lectures. What lectures you have to listen to. And I will give you some exercise on all these lectures. At the end of the week, we'll have a session, an online session or a session like this, where you can always ask doubts on all those classes, 5 or 6 classes which I mentioned. So all lectures are available. For all these lectures, I will give a complete schedule from day 1. Day 1, you listen to this, day 2, day 3, day 4, day 5, like this. After a topic is completed, I will conduct a test also. Okay? Any doubts that you have, I will give you one specific day. Suppose Sunday, I am just giving an example. Suppose Sunday, morning 10 o'clock. You can come and ask any doubt on the previous week topics. Okay? And I will conduct tests also. Regularly I will conduct tests. Every week most likely I will conduct tests. And all of these things, some of the instances, this doubts clarification, we can have it online also. If I am not in Hyderabad, I can have it online as well. So that nothing would be disturbed till the time you complete the entire course. Okay. Other teachers also. I will give schedule. Na? Online or offline? I will tell you that. I will tell you beforehand whether it is online or offline. Because whatever topics generally I deal, whatever topics that I have given you as recordings, okay, my lecture is there in that. I will take this clarification session, doubts clarification. The recording, some other teacher is there, that teacher will be there for doubts clarification. Because the same teacher should be there, right? Because the style of the teacher which matters here. Yeah, physically ga mana doubts clarification ke kalustamu. మిగతావన్నీ రికార్డెడ్ సెషన్స్ ఉంటాయి. Okay, and the entire recorded courses session I am not yet decided on that, because for the last 2 days I am thinking on this. So the mentorship is like, I will give you what to do every day. Daily what you have to do, I will give you the entire schedule. Okay, but generally what happens is in the recorded sessions, recorded course, entire recordings would be given there. You do whatever you want. You do whatever you want. Okay, that's up to you. But in this case, I will go with daily what you have to do is something which I am going to tell you. Any doubts that you have, weekly once we can meet. Any doubt. But we'll stick on those doubts to only the topics that I give in the schedule. Okay, because you've come and asked me of doubts related to another teacher. Yes, I can clarify them. But the other teacher would be the best teacher to clarify the doubts. Now, one more advantage here is that in these sessions, since they are recorded ones, you don't require to like afternoon 2:30 to 4:30 or 5 o'clock only you have to see those sessions. Entire day you have, suppose today you are not able to see them, tomorrow you can see 2 lectures. Obviously, online facility will always be there. And these recordings you can see in mobile as well as in the desktop. The only problem is that I will not be able to take so many classes. Some of the classes I can take, but see, if I commit, I have to complete all the classes, right? So if I am not available because of some reason, suddenly no class is there, it becomes a trouble for you guys. So I don't want that to happen for this batch. Yeah, tell me.
Access 10 months or 1 year?
Access, it extends beyond 1 year. It goes to 2 years. Don't worry. Don't worry about the access. I will take care of that. Minimum 2 years you will get access, or else it might be permanent affair. So assuming that my class is little slow, suppose you can put 1.25 speed or 1.5 speed and then complete it instead of 2.5 hours, you complete in 1.5 hours. It's all up to you because they are recorded. So you have those facilities. But only problem is that on the spot when you get doubt, I am not there to clarify your doubts. Because in the class, generally what happens is, the best part of the class is that any doubt that you have in the class, you can clarify that on the spot, immediately. That facility will not be there. That facility, one more thing, I will create a group also, wherein if you have any doubts, you can post that in the group. If I am ready, I have seen it little early, then I will clarify the doubt, or else others would clarify it. So we can create a group also in that. So that facility also I can. But taking daily classes for few days is okay, but not for 4 to 5 months. Not possible. This year it's not possible for. In fact, that's the reason why when some people came to me, I told them like, don't pay fee for maths. You pay for anything but not for maths. Let me clarify the things on today's, so that later on if you feel like paying the fee, you can pay or not based on whatever you decide on. Okay? Now I know it's a surprising element for you guys, but I've been thinking on this for past so many, because this year it's difficult affair for me. My schedules are a little tight. There's so many things that are happening, so I cannot restrict myself on these classes. Since already we have those many classes, yeah, mentorship is something which I thought like I should have started 2 years back. But anyway, now time has come for me to start this mentorship. Okay, the price components of all of them I will let you know in a day or two. You just give your phone numbers to the front office, okay, and they will inform you like this is the structure, this is what it is, and within 2 days I will give you the entire schedule also, entire course schedule, which day what you have to do, which lecture you have to attend. There's so many lectures, right? It almost goes to 5 months. All these lectures I'll put it in a sequence. Okay. The way generally we conduct classes, most of the things would be in the same sequence. You just follow the same sequence. Daily what I tell you to do, you do that. In a week's time, whenever you get doubts, you let me know that whatever schedule I give you. Okay. And then any doubts that you have want to clarify immediately, you post it in that group. That group, someone would address that. If I am there, I will address it. Because online, wherever I am, I can address it. Doubts are something, if it is there in Telegram group, I can always address that. That had been the case so many years. My old students, they keep pinging me, sir, I have a doubt in this question, can you please clarify that? I have done that so many times. And evaluation, your answer scripts also is something which I can do online as well as offline, both. Because it's weekly basis, right? So we can do that. And there will definitely be a test series also, which I will let you know, because right now we don't require any test series. Once your course is completed, only then you require test series.
So this weekly counseling session, how long is the duration of it? Is there
See, just only 1 week, right? So 1 hour to 2 hours. That depends on your doubts on it. You complete all your doubts, no problem. I'll be there till the time you complete your doubts. All doubts you can complete on the topics of that week, not which are going to come in future. Okay, because let us go in a systematic manner. If you want to do little faster also, it's okay. So it's not that I will not clarify your doubts. It's not like that. But let us try to stick to a schedule so that most of the people would be in that schedule. But if you are little fast also, is okay for me. Instead of 5 months, you complete it in 2.5 to 3 months. It's okay. Accept it. So parallelly, you start doing 2 topics, ODE and then maybe linear algebra. 1 lecture this one lecture that one, parallel if you want to do that. But my schedule would be for 5 months, 4.5 to 5 months. And doubts clarification is something which you can do it personally one-to-one also, don't worry. You can come to me at any time whenever you have doubts. That's okay. But as long as I am there, you can come and contact me. Here, this premises or that premises, Indira Park. It's okay. Got it? Any questions on this? Okay, na? Chalo then. So, these are the minimum basics you require. I tried to refresh everything, but I'm going to give you the soft copy of that. If you give a phone number to front office, they will send you a WhatsApp or a Telegram, whatever. They'll send you a soft copy of that. Okay? Chalo. Thank you so much, guys, but sorry that I cannot conduct classes this year. I don't have a choice, basically. I tried in different ways, but the problem is I can always engage other teachers to take up these classes, my classes also, but again, you know, most of the topics I have to take, because if I don't take, what happens is the orientation that you are supposed to get for this examination, that would be missing. Okay? So, I cannot help it this year. Okay? Chalo then. Thank you so much. Bye.